Ever wondered what keeps a high-speed electric train gliding along as if it's on an invisible rail of power? It's the utter precision of the pantograph, that roof-mounted pickup arm, kissing the overhead contact wire in one smooth, unbroken embrace. The moment that wire sags or strays, the pantograph can stumble, sparking arcs, shedding volts, and risking costly damage. That's why engineers obsess over keeping the line geometry laser straight and drum tight. Even a millimeter of misalignment can trigger nasty power blips, fiery flashes, and frustrating delays. In short, those taut, straight wires are the unsung heroes making every electrified journey feel seamless, quietly delivering the power that keeps us moving. So, how do engineers keep those heroes perfectly aligned? Let's peel back the roof and peek at the secret architecture overhead. Imagine a double-deck suspension. The lower contact wire is the electrified runway the pantograph glides along, while just above it, a beefier messenger or catenary wire shoulders the load. They're married together by a neat row of vertical droppers, tiny steel guardians spacing every few meters. Each dropper acts like a tailor's stitch, holding the contact wire at a precise height and sideways stagger. So even at 300 kilometers per hour, the pantograph never loses its electric handshake. Why two wires instead of one? Because a single hanging line would sway like a clothesline in a storm. The messenger wire carries most of the mechanical tension, keeping everything taut, while the contact wire focuses solely on delivering clean current. Those droppers transfer the perfect amount of pull. Too loose and you get sag. Too tight and you risk snapping. By fine-tuning their spacing and tension, engineers craft a silky smooth power track in thin air, ensuring trains slice through with zero hiccups and wheels humming. Now zoom out and see the big picture. Up top, that muscular messenger wire bears the weight, while dozens of little droppers hang like evenly spaced piano strings, cradling the contact wire in a dead-level line. Thanks to this two-tier ballet, the pantograph always meets a gold standard target. Same height, same side position, mile after mile. Shake off the droppers, and the wire would sag like a tired rope bridge. Keep them tuned, and the current flows so steady the train practically whispers, "Is that all you've got?" But guess what? One size never fits all in rail electrification. Over a century of tinkering, engineers have rolled out three main catenary flavors, each tuned for speed and stamina. First up is the simple catenary, a lone messenger wire holding a lone contact wire with droppers. It's the workhorse you'll spot on countless Indian Railways routes. Solid, dependable, but limited to shorter spans because beyond a few hundred feet, gravity starts to win. Crank up the speed and you meet the stitched catenary. Here, a bonus stitch wire links messenger and contact right at each mast, smoothing out tension where droop loves to appear. The result? A pantograph that glides through support points without the bounce, perfect for those sleek European high-speed lines eager to push the throttle. Need even more muscle and amperage? Enter the compound catenary. Think of it as the deluxe triple-deck sandwich, main messenger up top, an auxiliary messenger in the middle, and the contact wire below. The auxiliary can be a superconductive material, while the contact remains a tough copper alloy, giving you lower electrical resistance and rock-solid support. Older French TGV corridors and heavy-duty DC lines swear by this setup for its raw power capacity at blistering velocities. Each design is a calculated trade-off, simplicity versus speed, economy versus endurance. But they all share one mission: keep that pantograph locked in a perfect electric handshake, no matter how fast the future rolls in. So, now you know the backbone designs that keep trains humming. Simple, stitched, and compound catenaries, each playing their part to tame speed and power. But how do engineers make sure these wires stay perfectly aligned day after day? Stick with me, because in our next segment, we're diving deep into the clever engineering techniques, tools, and tricks that keep every overhead wire laser straight and rock solid. Don't miss it. Hit like, subscribe to Growth Mindset Company, and let's keep this ride wired for perfection.